know who I am. I was virtually reluctant, forgetting totally that I had a real session to share. So let's start the session almost in time. First will be my good friend Michael Linden, Dr. Michael Linden. He will be talking to us. So I think that the floor is yours. You've been in this position, so you have your time.
Thank you. Oops. So, good afternoon everyone. I'm Mikael Linden from Finland, and this speak is about Kalmar Union, a confederation of Nordic identity federations. And we have also Andreas Stulberg speaking, and he will show the technical parts of the Kalmar Union project. So, what is a confederation? We have a lot of confederations in European higher education. On Sunday, I counted that there are 15 federations now in European higher education, and a couple of federations in other countries beyond Europe as well. But currently those federations are national, and if you want to have end users from several national federations in your service, then you need to do something to bridge those federations together, and that's what a confederation is about. A confederation is a federation of federations. In Nordic countries, we have currently 4 federations: Haka Federation in Finland, Feide Federation in Norway, Summit Federation in Sweden, and the Waste Federation, which covers both Denmark and Iceland. And in Kalmar Union project, we have confederated these 4 federations. What kind of services would require confederation? This is the list we identified in Kalmar Union project as a potential service providers that would make use of having end users from several countries. The first use case is research collaboration. Research is international, and research groups span several countries. They have end users from several countries, several universities, and they have shared tools they need. For instance, wikis and collaboration platforms, portals, any kind of tools they need to support the research they are doing. And to go one step further, research groups have already also realized that the tools they need, the tools they operate are expensive, and it even makes sense that each country don't have some expensive tools of their own, but at least in the Nordic area where there are small countries, it could make sense to have just one installation of some research tool and then share the tool for all the 4 countries or the 5 countries in the Nordic area. And for instance, the GRID CA, the service providing certificates for GRID end users, is the primary use scenario we have been studying so far, so that we could have just one installation for GRID certificates, issuing GRID certificates for end users in Nordic countries. Then learning, e-learning materials. There are Nordic master programs which span several countries in the Nordic area, and they need learning management systems that are shared by several universities spanning several countries. And finally, any kind of content that libraries provide to the researchers and end users. Those library content providers could benefit from having the service visible in all the Nordic countries. So these were the use cases we found. And then to the Kalmar Union itself. We found that the first thing we decided to do is do the policy stuff, and then when we have the policy ready, we started to make an implementation that implements the requirements set in the policy. And the juridical shape of Kalmar Union is a memorandum of understanding and charter for the 4 federations that join the union. So it's a memorandum of understanding. It isn't fully binding, which lowers the threshold to join the confederation. It isn't that binding that it may be easier to sign the agreements when you don't need to have so many lawyers reading and deciding if that agreement is something that the participating federations are willing to sign. All the 4 federations in the union are and remain independent federations, and the IDPs and SPs, they don't join the union directly, but instead the IDPs and SPs need to join some of the 4 federations, and then the IDPs and SPs are confederated in the Kalmar Union. We have focused on privacy issues, and there's one slide about that. All the liability issues are excluded in the policy of the confederation, and also invoicing doesn't take place, so the federations in the confederation don't invoice each other for transactions. Privacy and data protection. We have the Data Protection Directive in EU, which sets the limits for what kind of issues should be tackled in the confederation as well. And since the confederation releases personal data between security domains, between national federations, the privacy issues were considered even more important than international federations. According to the Data Protection Directive, we have implemented a couple of practices in Kalmar Union. One practice is that only relevant attributes are released to a service provider, and we use the SAML metadata to indicate the attributes that are relevant for the service provider. Also, the end user is informed on releasing his or her attributes to a service provider, and the end users need to consent to attribute release explicitly. So that was my part of the speak, and now it's Andreas.
Hello. Oh, okay. Yeah, I'm going to speak about the technical setup of the Kalmar Union. What we try to do is to establish our address for you either use the wireless or TNC. I try. You better wait for someone to give you properly the wireless. Yeah. I know you would like to walk. Yeah, I know. I can point. You have to be close to the mic. Yeah. Yeah. Good point, Victor Ramos. Thank you. We try to establish trust between endpoints within one federation, one country, with endpoints in another federation. How we do that is using SAML2 metadata to bootstrap trust. What we do is that for each federation that I want to join or cross-federation or confederation is to publish a national aggregate of all the entities within their federations, both service providers and identity providers. I'm going to talk a bit more about what's inside that metadata. And also these metadata aggregates are signed, and we have a central server that is pulling metadata from all these public URLs, signed metadata, and provides a new metadata source with all the entities within the Nordic countries, or all the federations that participate. Here's another figure showing the same. We have end-to-end SAML, but the centralized metadata aggregation. You see all the identity providers on the left side and the service provider on the right side, interconnected with trust through the central aggregate of metadata. Here's the content of national federation metadata aggregate. You see it contains a lot of identity provider the entity descriptors, as well as service provider entity descriptors. It also contains a digital signature. How we do it, we are not using PKIX to bootstrap trust on the metadata. We have a pre-shared key, public keys between the national aggregate and the central aggregate. And it scales very well because there are not very many national aggregates. So this is the content of one identity provider entity or one service provider entity descriptors. This is just basic SAML2 metadata, but I go through it anyway because it differs very much in different contexts what you really put inside metadata. Of course, we put the entities SAML2. We embed the certificate. A very important point here is that we are very explicit on using expiration times in the metadata, because if you're not, you will not be able to in a proper way remove or revocate metadata for entities that should not any longer participate in the cross-federation. We have multilingual name and descriptions as are allowed in metadata. Important because there are in a federation spanning multiple countries, people speak different languages, so we try to make federations enter names in more languages. What is specific for the identity provider is that we include the scopes in the shibboleth style, like you are used to from shibboleth federations. It's even more important when you are connecting federations together, because then there are more trusted entities that could make bad things. Therefore, it's important to scope what I can do. Contact information of technical administration contact. Service providers is all the same. In addition, thing that is, I think we're doing something that is not common, but we embed the list
of attributes in the OID format inside the metadata, which is working pretty okay. I'm coming back to some details about that later, but small note about a technical setup. Entities that are connected as of now is mainly based on shibboleth or simple channel PHP. As far as I know, that's the only software that supports automatic metadata aggregation. Unfortunately, the commercial world has not yet understood the importance of automatic metadata distribution, but they will. When it comes to how we use SAML, it's important because there's a lot of different ways of using SAML, and there will be it's very easy to set up two SAML endpoints that do not understand each other. We have been working with a cooperation with some Internet 2 guys and other folks from the industry to start to work on SAML2 interoperable deployment profile, which specifies the minimal requirements of bindings that you should use and how you should encode attributes and how you should select things, how you use PKI and certificates and so on. And also, we are using the SAML2 metadata interoperability profile by Scott Cantor, which basically tells you how to embed certificates in metadata as a few other things. We are here not using PKIX as well, so there is nowhere in our cross federation we are using PKIX. That's everything that's needed to set up from the technical side configuration. We have some additional features that may make it easier for service providers and identity providers that are not necessary, are not required. We have a centralized SAML2 discovery service, which is using the Idp Discovery profile from SAML2 to allow the user to select what IDP to select. We have a tagged interface using tagging in metadata to tag which federation you're from. I don't think it will be used by very many services, because if you are going to use a centralized discovery service, the entities that you are going to present have to match for all the service providers that use it. I don't think it will. At least it's a very good service to have for those that do not want to operate their own, that happens to want to connect to the exact set of identity providers. Another thing is attribute release policy shibboleth style file, because I don't think shibboleth is supporting automatically having attribute release policy from the way we put it in metadata. So what we do is centrally generating our file, which shibboleth supports to automatically download and trust. So we have our file that is generated as well as the central metadata. Some federations are already using centralized ARP files. That's my slide. Back to Mikael.
So some of the findings in Kalmar Union project were some homework, some harmonization action items for the participating federations in Kalmar Union, and we proposed this also to other unions and other confederations that may follow Kalmar Union. We found 5 issues to harmonize, and the first issue is attributes. All the participating federations in Kalmar Union have separate set of mandatory attributes, which is a bit difficult for the service provider administrators to adapt the different practices in all the member federations, and also the semantics of attributes differ slightly, and that's difficult for the service provider administrator if especially those attributes that are used for authorization differ from each other federation by federation. For instance, how the education affiliation values are interpreted in the different federations. And the unique identifiers that are used in the member federations, if education principal name is used as the unique identifier of the end user, what is the policy of recycling or reassigning the EPPN values for end users? Currently they differ in the member federations in Kalmar Union. The other way around is to go to education's targeted ID or SAMU2 person ID. But it's also a policy decision. If it's done, then all the member federations should adapt the policy. Campus identity management means the quality of management for identities behind the identity providers in the member federations. Should there be some kind of minimum requirements how identities are managed? Is there face-to-face initial authentication when a new student or staff member comes to the university? Is there some limited some time frame when the account should be closed when students graduate or employers leave the organization? Stuff like that, it could make it easier for the service providers to know that all the member federations have some floor on campus identity management. Usability and user experience is something that needs more work. Andreas showed the Discovery service, and so far it works, but when the confederation grows in terms of number of member federations, and also some federations have a lot of home organizations, how to make it usable for the end users? Well, SAMU2 profile. Currently we are using the SAMU2 simple profile in Kalmar Union, but it still needs work to do. What kind of features of SAMU2 are really mandatory for a confederation? And finally, the business model for the member federations. The biggest issue we found is that the policy that the member federations in Kalmar Union have for invoicing external content providers like library content providers. Some federations may invoice the external content providers and the other federations don't, and it may cause difficulties for the external content providers to adapt them to the different policies in that. So, conclusions. Yep, we showed that it is possible to have a confederation, and there are also use cases for confederation. Our conclusion is that the confederation project should start with designing the policy for the confederation, and the policy then implies requirements to the technical implementation of the confederation. So first start with the policy and then go to the implementation architecture and actual implementation of the architecture. We also showed that there's no need for bridging elements or any other kind of protocol gateways in a confederation. In Kalmar Union we use SAMU2 end-to-end, and we thought that it has several benefits for availability and privacy perspective, and also from usability perspective that there are no protocol gateways in place. And we also found that some harmonization of the participating federation is recommended to make it easier to confederate. So that's it. Kalmar Union has a website the web URL is over there. And we have also written a full paper on the details on Kalmar Union, so you can download that from the conference website. Any questions? Thomas?
Michael, which of these use cases you listed are now in use day to day?
Which use case is used day to day? Well, I think all the use cases could be used day to day. Learning management, for instance, e-learning.
I wanted to know which ones are in use now today.
Now?
With the Kalmar Union, how much is it productive or how is it a pilot? That's my question.
It isn't not yet in product in that sense that it's used day to day. Our plan is that when the fall term starts in the universities, they can rely on having the union in production.
Thanks. Hi, Michael. John Pashew from London School of Economics. You mentioned that there was a policy decision already that informed user consent for attribute release was definitely a requirement. And towards the end you mentioned that there were some usability issues to be sorted out. I know there are some usability issues there. And we've seen a screenshot of your WAIF and how that's navigated by users. I wonder if you've done any work on whether you can show users some informed consent information which they can actually be informed by.
So you mean how to make the consent informed, how to inform the end user that he is consenting?
What's the user interaction like for you to inform them and then to consent, and does that work?
Currently it varies in federation by federation. In Hakka Federation we have a practice that we show the link to the privacy policy of the service provider when the end user logs in. But that practice is currently local in Finland, in Hakka Federation. In Hakka Federation we gather the privacy policy URLs of the service providers at the time when the service provider is registered to Hakka Federation. But the other Nordic federations don't have that practice. So they only provide the information that this is the service, the name and description of the service to which your attributes are going to be released, and do you consent yes or no. And the service providers are only, the policy says that the service providers need to have the privacy policy available somewhere in the service, but it isn't provided as a link to the service provider.
I think it would be interesting for you when it's operational to do some measurements of the percentage of users that actually, you're not going to be able to measure how many users read it, but at least you could measure how many users actually click the link and display it on their screen. You better provide for a number of decimal places for that percentage, I think, in our experience.
We could make some exercise in that in Finland.
Is it working? Yeah, it's working now. So now we have the only solo presenter this morning or this afternoon. It's David Simonsen that will be talking about WAIF. Where are you from? So he's from WAIF, and the floor is yours.
Thank you very much. Okay, this is the longest title I've ever had to talk about. It's called Trusted Third-Party Based Identity Federation lowering the bar and for connecting and enhancing privacy. And let's get on with it. What is a federation? I'm going to walk you through a few basic steps about how we see a federation and what it is. A federation is a very beautiful thing. It's a green circle, and if you look around, you see circles everywhere. I noticed there are circles in the ceiling, in the loudspeakers, even the eyes. Round. A circle is a beautiful thing because it includes and it excludes. It has a borderline, and you know usually where if you are within or without. Now, the federation is a collaboration in a specific area, and in this case, it's a circle of trust, as it was coined by the Liberty Alliance some time ago, and it's about electronic identities and user information. Now, you have to get into the lingo here, so a few more basic things. Well, yes, here's a map of Europe and America and Australia. You have circles of trust everywhere, and they are either emerging in pilot or in production. The red circles here are representing the kind of structure that I'm going to discuss today, hub and spoke model, and I'm going to tell you what that is an alternative to. But an identity provider is a very important thing to know about when we talk about federations. It's called an IDP. You just have to learn the lingo. Usually it's an authentication attribute releasing entity. An attribute is a name, a role, some claims about you as a user. And these are the attributes flying around in space here. And then where do they go? They, of course, go to service providers. These are the interesting bits. This is where the users want to go, and this is exactly the attribute that is flying around there, and the service provider is trying to catch it, is showing that this is interesting information because it either allows you to enter when the service provider knows something about you, or they can leave you out. Federations then, these collaborations, what are they all about? Well, many things. One could be scalable and better role-based access management. Make it easier to decide whether you want a user, or whether you want to let a user in or not. It could be scalable and better identity management. You have to know a lot about your user, and you have to be able to trust this information. And this is a great part of what federations is all about. More services to the users. I think that's a very important one. And the other way around, more users to the services. You can now set up services and deploy them and get users to access them more easily than you could before. And you want to make better services. And I'm going to show you a beautiful, it's a fantastic photo. This is one of the best, largest killer applications ever. You have a telephone here in the middle. In the beginning, you couldn't call a lot of people, but it was working. I think that's about the state of the app, or just past. Now you have old people and you have young people, and they of course started to call each other. And then you had companies selling this, telcos, they interfederated. All of a sudden you could call anywhere. And now we have a mobile phone each on in the pocket, and we call our grandchildren or grandfathers or grandparents all the time. This is, in a sense, a kind of federated model, and you had a killer application that really exploded and went all around the world. So the basic concept now is a user with a browser on the internet, the wild internet, is trying to access this service which is in a security domain of its own. Let's say that. Now they want to let you in if you are the right kind of user. So in order to get this information, they don't trust you. They trust somebody that will claim something about you. And you have to go somewhere else, choose where you're from, log in somewhere where they know something about you, and then they will pass on the information to the service, which can then decide. So the authorization about if you're being let in or not is always decided by the service itself. Of course there are exceptions, but let's say that. Now, I'm going to tell you about what happened in Denmark. I think Ken referred to this as a rise. We started about 5 years ago, and we wanted, of course, being so much behind many others, to do and copy what exactly what they did. So we tried to set up a shibboleth federation, or what I would describe as a loosely coupled federation. Institutions, service providers, and a WAIF. And we used Shibboleth. We spent almost 2 years setting it up, and actually not much happened. I'm not going into great detail. There's a paper on this talk. The talk is following this paper very closely, and it's up here in printed version, so you can go into more detail there. So as the standard Shibboleth federation did not work, we looked north. We went to Norway and see what they did. And they actually have a central login page connecting services here and connecting institutions. We thought this is perhaps more or less the opposite, but it might work. So we tried to introduce the idea, and it failed. It did not work, so we had to come up with something different. And that's actually the aim of the talk today. This model here, where we have decentral login at the institution side, but still a very centralized model where all the information is passing through. And I'm going to tell you more about that, because today's menu, we have to eat a lot of different things. And setting up a federation is really a lot of cooking and a lot of preparation. And to taste good and smell well, then you have to know a little about what is going on in the kitchen. So, for starters, we're going to talk about institutional branding, extending single sign-on, and single point of contact. Then we go to the paella. Main courses. This is about protocol translation, central consent service, calculated attributes, opt-out. I'm going to explain all of this to you. Central attribute release policy, and then, of course, dessert, legal status, data processor, interfederating made easy, and future work. Now, in a menu, you can pick a few, or you can take the whole menu. I'm going to take the whole thing and prepare it for you. Institutions are very proud entities. Now, I'll give you some examples here. You have one university promoting multicultural environment. You have a Nobel laureate here, and you have a university which is all even presenting students and young people. Now, they have these portals, and this is where their users are passing by daily. And they're very, very aware that this branding thing is something they have to be aware of in the competition between the universities. So when we introduced this model with the central login system, the Norwegian model, they didn't even look up. They just said no. This is not going to work. And that's actually one of the crucial points in deciding to go for decentral login. Be aware that institutions want to brand themselves. They want to have a role in this game. Now, extending single sign-on. What is happening here? Back in the old days, single sign-on systems were not that widespread, but they are now. And single sign-on is when you log into your institution and you get access instantly or automatically to a lot of services. And these happen usually within the institution's own security domain here. So you can get access to all the services in here. Now, this federation model here, all of a sudden can extend this to all the services connected to the federation here. There will be user interaction, there will be user consent, and so on. They might even have, from time to time, to pick where they come from. But you can all of a sudden now build a system where you have single sign-on, which extends far beyond what the usual security domain is. What we're looking at the moment is how to establish this session so you actually get this when you log in here, automatically propagating all through the system to all the federated services. Here comes a really interesting bit which has been a driver. Single point of contact. An institution connecting to this kind of federation structure. Make one connection, one technical connection here, and makes one agreement with the federation operator, and that's it. Through this single connection, they get access to many services. So when a new service arrives at the federation, they don't have to change anything. Just go on as they usually do, and many, many more services will come on, as we will see later. And the same goes for the services. A service connected to Wave here has one technical connection and a contract. And then as users are being attached via their institutions here, the marketplace, you can say, is growing, and they don't have to do anything. Of course, they have to sign up contracts. If they want to get money for their service, they have a contract with the institutions, but that has nothing to do with the federation. The federation is just the technical and, to a certain extent, legal glue that binds this together. So you can get access to many services through a single through a single connection, or you can get many, many users accessing your service through one contract here. So this is about more services to the users and more users to the services. Now, this is about role-based access. And how do you then now get to this service? Well, we saw before that you have to release some information from the institution's domain to the service domain here. Now, as we only have single connections at the on the institution side and single connections on the services side, you can see that so far we have only been able to make a one-size-fits-all. This means when we connect a service, we write in the contract which information goes to the service in order to decide whether to let the user in or not. So if the service needs my name and which institution I'm from and my email address, that will be the three pieces of information which will be transferred from the institution to the service, no matter which institution I come from. And there are no exceptions here, so everybody has to fit in and agree with this attribute release policy. And of course, this puts the federation operator in a tricky position, because we have to negotiate correctly the amount of information which should be sent to the service. But it's not very unlike what is happening in shibboleth federations, where you also have attribute release policies. I've been discussing this with Michael, and what seems to happen is that the federation operator defines an attribute release policy and distributes it to all the IDPs, which then just eat them and release whatever is suggested. Very few IDPs actually hesitate or actually refrain from following the provided attribute release policy. So both the federation operator in both cases of the shibboleth federation and this one have a huge responsibility to actually make sure that the attribute release policy gets right. So a one-size-fits-all for sending out attributes to services. Protocol translating. You know this guy, C3PO, he speaks 1 million languages. He can translate all of them, which is a very nice feature, and we can do the same, only not with 1 million, but let's say 5 or 6 or 7. Setting up the technical connection to the federation here can be done using SAML2 or shibboleth or CAST or LDAP or something else. The good thing about this is that we can now support whatever they have on the institution side already. They don't really have to install anything new. We help them a little maybe, or they can get it done by themselves, and they don't really need yet another box here. We can then translate this into the federated language which are being used on the service provider side. And this happens on the fly, and you should know that this is done using simple SAML PHP, which is written by Andreas and others also. So this is the C3PO in the middle, translating whatever protocol we actually allow within the federation. And this has been a key point, because we can now quickly convince institutions that they don't tie into a single protocol now, and they will be bound by this forever. They can actually change this, or we can change that, and nobody would really notice because we can do the translation on the fly. This is a crucial point when you start to talk about interfederation and connecting other services and so on. We hear a lot about SAML2 in this room or at this conference, but the institutions connected to this federation never hear about SAML2 unless they really want to. And they don't have to. And they won't have to in the future either. That's a good thing. A lot of discussion is going on about consent. And what is a consent? Well, it's an acceptance that information about you is being released to someone else. Oh, let me go back here once. So what we have here is information at the institution. They know something about you. The information is supposed to go to a service provider, which is certainly not within the security domain of the institution. So it's passing somewhere else. In a plain shibboleth federation, the institution will, or the IDP will then have to install a box which actually does this consent collection and management. But we're so lucky that everything is passing through this system here in the middle, so we can provide this centrally. So it just pops up, and they never heard about it before. Of course, we told them, but they forgot. And we can actually provide the user with this service that they consent. We ask them every single time information is being sent somewhere else, just to be on the safe side. And one more thing, we can save this consent information so they won't be asked the next time, and they have a consent service available so they can also withdraw this information, so it won't be sent automatically anywhere else in the future. There's a poster out in the hall, and I will be there by it, and we can discuss much more about consent. What the next thing shows is an important thing about consent. You should always, or you must always be able to withdraw your consent. This is legal stuff, and as I said, there's much discussion going on about it, but we've had good conversations with data protection agencies and consumer protection agencies and lawyers and so on, and they all seem to agree. Even the Danish Association of Industries, which that's a very powerful organization, they're very happy about this and very concerned about privacy. So in the Danish context, with the Danish law, this seems to work very well. Now these attributes, this information about you, is usually being sent from the institution directly to the service. But we can also have attributes that are not originating from the institution or the IDP itself. We can set attributes about you as a user. In the case you come from institution number 2, they are not allowed in our federation to actually claim this. We will do that because we know where the data came from, and they're not allowed to spoof or being able to spoof that they actually have users coming from a different institution. So we will tell the service where the data originates from. That is what we call a set attribute. We have an attribute called shared year of birth. It's pretty much self-explanatory what it does. But if we get this attribute from the IDP, of course we will just let it pass. If we get a social security number, which we do in some cases, we can calculate this, and that can be used for age verification and many other good things. So that's an example of a calculated attribute. And another one, which I will go a little more into detail with, is person targeted ID. It's actually in principle very simple. It's a pseudonym that you as a user get at different services. So here am I at this IDP. I want to go to 2 different services. I want to be recognized. The service is supposed to know that this is me again, but they're not supposed to know who I am. Just being recognized. And these are 2 pseudonyms. They're pseudonyms because they're the same every time I go to each individual service, but they're different. So the services cannot data mine among them and see what I did at this service and what I did at that service, because they don't know who I am and they can't recognize me across services. Now, this is a calculated attribute, and what makes it different from the normal eduperson targeted ID is that we get information about the user, we do some magic, we have the formula to calculate the pseudonym, and we deliver the results to the services. Now, if we want to or must find out who this user is, usually in a shibboleth federation you would just go to the IDP and say, can you please calculate for us who this user is? You can't do that in this setup. Here you have the results. This is the user we want to know who is. And if they go to the institution, they say, we can't help you because we don't have the formula to calculate eduperson targeted ID. So we have to come together, 3 different bodies, the service provider with a user pseudonym, eduperson targeted ID, the federation operator with the formula how to calculate this, and the institution with all the user data. And then we just run the formula on all the users and see which one matches. It takes a very serious case to actually start this machinery up. But the user can be absolutely sure that the service provider cannot just go to the IDP and find out who it is. And for those of you who read PHP, you can see this is the formula we use. You can see it in the slides afterwards, but it's not just like that. This is very difficult to get, and very, very opaque. And now also very, very secure, since it takes 3 bodies to actually find out who that user was. You're getting a real shower of information here. Opt-out. Opt-out means simply that if we connect a new service, all IDPs can access that service. They don't have to tell us that they would like to get to this service and so on. They can just go directly to it. If they don't want to, they can tell us it should be disconnected for their IDP. Of course we do that. And then we will block, so no attributes will go from this IDP, let's say, to service X there. And as the federation grows, this is going to be a hassle. So we're building the Joint Administration Net-Based User Self-Service. It's called Janus for short, and that's the name of one of my colleagues' son. So we have to find out what that would stand for. It's being developed, of course, as open source. This will be attached to Simple SAML PHP, and you can go to this URL and see what the progress is. We're almost finished. I think we have 23 or 24 use cases, and now we're coding all the stuff. And it's almost all in English. It will be soon, and you're more than welcome to comment on it. But the first release will be here late June, and by New Year this year, I think we will be operational with the system. Now for the dessert. Legal status. All this policy thing is a pretty complicated business. And when you talk to lawyers, you think first it's very expensive, they're taking all my money. But you have to be aware that some of them at least are pretty smart people, and they can simplify what you're doing greatly. And what you have to know is that it's very hard to discuss who owns data. Is it the institution who owns the data, or is it the user? Some claim that when data leaves the institution, the user owns the data. And that's a very tricky one. But what I have found out to be solid ground is that there are 2 roles you can have when dealing with data. Either you're a data controller. Keeping data about users makes you a data controller and very responsible for that data. Or receiving data about a user makes you a data controller and very responsible for that data. That's why you have all these privacy policies that have to be shown to the user and so forth. Now, there's a different kind of role here also. That's called data processor. A data processor is not as liable as a data controller. And the auditing requirements for a data processor are certainly not the same as those for a data controller. The wave federation, as you see it here, is an empty shell passing on authentication requests and responses. Requests this way and data the other way. And when it has passed, it's gone. We have no information lying around here about the users. And this way we have been able to get the status, legal status of data processor. So when a service, an institution or an IDP connect, they agree that we act as data processor on their behalf. Now the tricky thing when setting this federation up was legally to find out whether this entity can be data processor at the same time for many IDPs. And that's possible. And it's possible because we don't keep any of this data here, but we have a certain set of functions that we do for all of them. And you should be aware of this when setting up a federation or operating a federation, whether you become data controller or data processor, because it's really, really hard auditing you get to face if you become data controller. Interfederating or confederating. Now, seen from our point of view, it's getting a lot easier. Now, the red arrow here indicates that we have connected Iceland. So Iceland is actually part of the WAVE Federation, and now we have the Kalmar 2 union running here. And we have already seen it. It's a new thing, and it's a new thing to the service providers and the IDPs as well. And what happens is that, well, this is just one way of showing it. Here you have SIDE, the Norwegian Federation, where they have a single point of authentication in the middle. You have WAVE here with a decentral login, but still a single federation point here. And then you have HACA and SWAMI as shibboleth federations. And how they connect is very different, because there's only one IDP or proxy IDP, whatever you call it. There's only one point of contact for the IDP, from the IDP's point of view, to the outside world, and that's through this gateway, you can say. There are more details to it than that, but you can actually see it this way, that it becomes easier to connect to Kalmar when you have a centralized federation like this. I'm getting to the end, the bitter end, and I'm going to just release some of the things that we will discuss with you and seek help to solve in the coming time. Now, there's lots of things to consider here. What if a server never authorizes users from IDPX? Do they really have to go through all of this just to be rejected? Or can we help them earlier on? How do we present to users that an institution is not letting their users going to use a certain service provider? And we're already discussing this with Hans Strandberg and other good people, and there are many things to do in this area. Now here comes one really tricky one. Why should users trust the central component here, the WAVE in the Danish case? WAVE Federation. Why should they use it? They meet this thing on their way. It's a new thing to many of them. Why should they use it? Who should teach them to trust us? The institutions, or should we? We had this discussion also with DataRoam, and it's a delicate one. But apparently it's not much of a problem because people are not complaining a lot, but we should be very much aware of this. Should the federation be completely invisible? I'm sure we can do this technically, but do we want to do this technically? How do we aggregate and present to a service provider attributes about you from more than one IDP? This is something we already have a prototype of, and much more work is going to be done there. It's a really interesting question, and we have some very good use cases already. We also see that service providers don't want to go by the WAVE. They want to have their own list of institutions that users can choose, and how do they do that? And all this essentially comes down to usability. We want to provide something easy to use, beautiful technical solutions, of course, but usability is really the word, and that's where we're going to fight a lot of fights. So with these words, I will thank you and ask if you have more questions at all. Yes.
For surfing actually, we're also looking at user consent at the moment, and what I was wondering is whether you've done a user study, how your users respond to the fact that they have to consent to their attributes being released.
We didn't, but the Spider guys, Andreas and others, did in Norway, and they have a real study on this, where you can actually see how people reacted. You are? Yeah. So the UK is doing the same. That will be very interesting to see.
Another question regarding the release of attributes. It often happens that you have an SP who wants attributes that the IDP can't or won't, but mostly can't provide.
Yeah.
As you have a central thing in between and the ability to be an attribute provider, what is your policy to this? Do you provide attributes that the SP wants and the IDP does not provide?
Well, we don't have any attributes in the middle. It's just an empty shell. There's really nothing there. Everything has to come every time from the IDP through to the service. So we can't provide anything else.
For example, the SP wants an email address and the IDP cannot provide it.
Tough
luck. Okay.
Yes, sure. Yeah, well, I could invent an email address, but I doubt it would work.
You could calculate something like at institution dot.
No,
whatever.
absolutely not, because we can't deliver anything to the IDPs. We can't send anything backwards that they would actually incorporate in their directories. So if this service is interesting enough for the IDP, for the users, then they will provide the attributes in the end.
Thank you.
David, have you and Wave thought about how you adapt to providing identity to non-web applications? Because that's where we want to go. And you have this web browser, and I don't want to stick a web browser in front of everything.
No, well, that has not been the primary use case. But we're starting to think about it, so we will stay tuned in this group.
Looking at your legal positions diagram there, it occurs to me, I'm not familiar with Scandinavian country law, but it occurs to me that you could allow some of your service providers just to be data processors rather than
just to be
data processors, have the lesser liability of being data processors rather than data controllers, if they wanted to merely use the attributes to make an access decision and then throw them away. And maybe if they were merely retaining something like eduperson targeted ID to flag to identify a log record, they would merely be a data processor. And someone like that.
Well, we went through this in great detail. and a sidetrack to that is the people we went through it with is a law firm which is the legal advisor to the government. So we paid a lot of money to save time later on and to get the best advice we could. And the thing is, when they receive this data, in that moment, they become data controllers. They can throw it away. Yes. But somehow, as we have stated that these things are just passing through, it's up to them later on, if there will be a case, if they want to become data processors, to actually show to the world that this is how it works, and then perhaps, and if this is not going to be me, someone will judge that this is a data processor. I'm staying out of business there. But one point I want to make is that lawyers, good expensive lawyers, can actually shut down a lot of discussion later on about all of these things. Universities, many of them have legal departments. They want to have a look at this. And in our case, when we came with a set of agreements and they were dealt with by this company, we had no more trouble.
I think even very expensive lawyers don't necessarily understand the technology and the technology of data being there for a very short time. But I understand what you're saying.
Maybe we were lucky.
Okay. It's a follow-up to Ken's, I think perhaps something to add for the future work. We are thinking in offering a service where a service provider with a native person targeted ID can provide that to the identity provider in order to find out whether this account still exists. So with the normal shibboleth installation, it's rather straightforward, we hope. That might be perhaps a challenge for your hub and spoke model then.
I think it would be impossible actually. Yeah. Not a quick one.
Yes, since we are from the red circles as well, I would say that it, at least thinking on how we have made the whole thing, I think it would be possible.
Yeah.
What Thomas? We have to think about it. I think it would be possible.
We will see.
Well, we the reds are the ones, the good ones, you know.
Okay.
Thank you.
I was just. I cannot take sides being the moderator today, but many of you know which side I'm in. I will not tell now. And then we will be in the fashion of these TNC of duo presenters. This now will be Hans Sabel from SUSNet, and I cannot pronounce your name, I'm very sorry. So Hans, would you like these and you can move around, or you will be standing still in here? Okay, Jos, we will take care of you while he's speaking. Okay, so the floor is yours.
So David, thank you for this presentation. I think we're running late, but I think you also told about 50 or 70% of what I was going to say. So that's very good. Just like WAVE in Denmark, the Netherlands runs a federation called Surf Federatie. I will pronounce it as Surf Federation from now on, which is a central hub. A hub and spoke model, a gateway, a proxy, whatever you would call it. And I think we have to align some terminology here, and we would like to call it identity as a service, which is totally buzzword compliant, so let's stick with that. An overview of the talk that I'm going to give. Halfway of my presentation, Joost will take over and we'll talk about some SurfNet specific stuff that we do. I will dive into the technical details of our federation, which aligns so well with the WAVE model. So federation models, I can basically skip that one. Looking at the shibboleth model in the middle, where you have connections between IDPs and SPs, all based on the same protocol. This was not an option in the Netherlands. We had an installed base of ASELEC, and we were having stubborn universities that were insisting on using Microsoft technology, which didn't implement SAML2 at that time, or ASELEC for that matter. So we had to invent something just like WAVE to come up with a hub and spoke model where you introduce protocol translation, which enables each of these different technologies to talk to each other. So in the middle of our federation, we have a gateway that operates as an IDP to SPs and operates as an SP to IDPs. So the functional view is that we have central federation components. In fact, we have a few of those. It's not just a single software component, which handles a number of different protocols. Protocols being ASELEC, SAML2, and ADFS. Especially ADFS is necessary in the Netherlands, where we have a large Microsoft installed base, and it's in ADFS. It's just a matter of installing a server with within 2 hours you can hook up to the federation, which is probably not an option if you have to introduce a shibboleth software and get used to that and maintain this software. So at the other side, the connection to the service providers, we also have the shibboleth 1.3 protocol. We don't need that on the IDP side because we don't have shibboleth 1.3 IDPs. And when IDPs want to connect with shibboleth, we point them to shibboleth 2, which implements SAML 2. So how does the authentication flow look? A user accesses a web service that is shielded by some software like shibboleth or aselect, and the user gets redirected to the central gateway with a specific protocol. The protocol is translated, authentication request is sent in another protocol to the IDP, and then vice versa. Basically what David just showed us as well. Okay, maybe I... Yes. Okay, yeah. A little view on the deployment of our service, the actual implementation. Because the gateway is the central component, we have to make it both scalable, it has to scale, and we have to make it the availability very, very high. So we introduced a model where we have 3 servers handling the same functionality and being interconnected to handle all of the authentication requests. We use round-robin DNS to share the load between the servers, and this means that when clients behave normal, every server gets the same amount of requests on the average. We have one management node that we use to inspect the state of our gateway, and we have a failover node which is in a different geographical location than the rest of the nodes. So when something serious happens to the connectivity to our gateway, we can make it up and running in another location by having a DNS change. A server node runs a bunch of software which is depicted here. We use Heartbeat for failover, so for IP address failover. We use SendMail a lot for debugging purposes, for sending notification messages about what's happening, for bogus attempts to send authentication requests to the gateway will be notified. We use Memcache as just like Simple SAML PHP does, and as Andreas explained to us, which is a very good way to handle SSO sessions because it's very scalable, it's very fast, and well, if you lose a session, it's just a matter of re-authenticating for the user, and no harm is done. We had a MySQL cluster before, which was actually not necessary for keeping session state with SSO sessions. We do use MySQL for logging, for keeping detailed statistics and detailed logs, and we generate reports from that. We use mod FCGI and PHP and CGI mode to handle more requests per minute, so instead of mod PHP. And we use 2 types of application software, so to speak. Ping Federate, which is a commercial product which handles ADFS connections and SAML2 connections. And we have software that we call PHP Federate, which is much like Simple SAML PHP is, doing some of the protocols. And these all, the Ping Federate node and the PHP Federate node software communicate together, and they operate as a single functional entity. Connections so far, we have a number of IDPs, like 5 IDPs connecting using SAML2. We have about 15 using ADFS, about 10 doing aselect. Aselect as a product does not get developed anymore, so we expect that in the coming years people will switch over to a different product and a different protocol, which is possible because just like in Denmark, they have a single connection to the gateway, so this is made easier. SPs, we have 5 connecting using SAML2, Shibboleth 1.3, 5, and aselect 3. And the number of federation products that is being used in our federation is actually quite diverse, which is very good because it shows that the gateway concept works. But of course, the diversity makes it harder to maintain all of the different connections. So a word about the implementation. It's done in PHP. PHP is used everywhere, so to speak. It's an implementation programming language, but we also do our configuration, and our metadata is stored in PHP. It's also a configuration language and a processing language. For example, for processing attributes, just like the code that David showed, we can alter attributes, we can inspect attributes, and we can process them. It's also a provisioning tool. We provision connections to the Ping Federate server using their API, so we don't have to manually configure SAML2 connections, but we provision them from PHP. What we have is that every IDP appears in every protocol. So an A-select IDP is also visible on the gateway as a SAML2 IDP and as a Shibboleth 1.3 IDP. This is one of the things that sets it apart from simple SAML PHP. There are two options for connecting to the gateway. As an SP, you can choose to see all of the IDPs, or you can connect to the gateway and see the IDP, see the gateway as the only IDP. Some of the SPs really want to connect in the most simple way, and then we handle, for example, the wave functionality for such SPs. So some of the features and some of the decisions that we have to make in this setup is, up to now we have a pure stateless switch. Just like David explained, there's no stored information in the gateway. It only translates protocols and passes around data. Of course, one of the things that we could do is introduce state and, for example, inject attributes on the gateway into the assertions that are sent to services. If we start doing that, we have to think about the liability. We have to think about the availability of those databases and stuff like that. So this is one of the features that we are considering right now. So we have the logging statistics, which is an important element here. We provide this data for internal operation, but also in the future it will be distributed to our IDPs and SPs. They don't need to maintain logs themselves because everything is running through the gateway, so we can do the statistics over there. We have the option of doing so-called personalized IDP discovery. When you get access to a service, it doesn't automatically mean that you get the full list of IDPs presented to you. We only show the IDPs that do have an actual contract or relation with a certain SP. We have features like step-up authentication. We can introduce OpenID gateway functionality on this gateway, so we don't depend on each and every IDP to implement functionality like that, and we can do that for our IDPs. And this is why I refer to that as identity as a service. And optionally, we can introduce management APIs, web-based GUIs, where our institutes can log in and maintain, for example, user consent for their users. So our experience so far, we definitely see that multi-protocol abilities speed up the deployment. Institutes can connect using the protocol and the product they want. We see that identity providers are happy that we are doing some of the work for them. They don't have to configure attribute release policies themselves because they outsource it to SurfNet and Surf Federation. We also see that SAML2 implementations are hard. Technical knowledge on SAML2 and the products that implement SAML2 is apparently hard to find. We see a slow SP take-up. Our IDPs are connecting pretty fast, but SPs are more reluctant. probably because they need to change more in their services, but this is where we have to work on in the coming year. Scalability of the gateway, one of the perceived disadvantages of a gateway is the scalability. Well, we have calculations that it will scale easily up to a national level where we have 1 million users. And then a word about the trust model. One of the perceived disadvantages is also that there is the trust path between IDP and FP is broken in a gateway federation as opposed to a shibboleth federation where the path is end-to-end. Well, we had some discussions on that in the last month, and if you look at a shibboleth federation where you have a trusted third party that publishes metadata, this is actually functionally equivalent to having a trusted third party running a gateway, because the federation operator can change metadata as well as it can change the gateway to handle attributes. So this is one of the conclusions that we made, that in terms of trust there is no difference between a distributed and a centralized federation. Future developments, I think I will have to skip over that because of time, but we're definitely looking at WS Trust and being a secure token service in that terminology, because it really relates well to central gateway concept. We are working on confederations, definitely in Edagain, and with this I will give the word to Joost. Unfortunately, Joost, we have an old set of slides here, so it wasn't updated. I think your slides are not in here. Cool. Yeah. Right. Yeah. Good plan. Yeah.
Okay. Well, my charming assistant is taking care of the slides. I'll introduce myself. I'm Joost van Dijk, ServNet, colleague of Hans. I'll be talking about ServNet as a service provider connected to our own federation. So actually, ServNet plays 3 different roles in our federation. One is the role that Hans has been talking about, operating a federation. Also, we're an identity provider to be able to have our own users connect to the services that are connected to our federation. And we also offer services ourselves through our own federation. So ServNet is just one of the service providers in our federation. And what's interesting is that we use the same software, part of the same software that we use on our gateway as a proxy in front of our services. Thank you. So this is called PHP Federate. It's just a component of the proxy. So if we draw a picture, this is what has been discussed by Hans. I'll be zooming in on one of the service providers, namely ServNet. And well, the idea is that we have multiple services connected to our federation, and instead of hooking up those services one by one to the gateway, we do so by an intermediary proxy. So this is a PHP Federate as well, and these are the services that are offered in our federation. For example, Serve Media, it's like for higher education, mail filters where users can configure their spam filters, etc. Serve Domeinen, that's a DNS, hosted DNS web interface. And these services are offered to our users. Well, instead of hooking them up directly, we use a proxy to provide additional services in a shared way. And I'll get some examples of those. For example, technical people from our institutions, they are able to have access to self-service web applications, and they have some role in their organization. And depending on the role, they can have access to different services in different ways. And those are used across services. So we have a central point where we can administer and add these attributes to the service, before accessing the services themselves. So to sum up some of the benefits of having this proxy, those are listed here. For example, central point for access control, for attribute enrichment, which I will be talking about a bit in a moment. Providing guest access to people that are not already hooked up to our federation or that don't belong to our federation but do need access to some selected services. Also be able to migrate users if they switch IDP, for example, a student that has been leaving a University A, joining University B, and who may have some content left but using his identity from the first university. So this is a central point where we can have the user migrating himself from his former identity to his new identity. And also the benefit was that we can do protocol translation. Some of the services are developed in-house, some are third-party applications. Well, we don't have to choose a single protocol. If it's a shibbolized application, we can hook them up by using shibboleth. And if it's something else, we can just we are very flexible in hooking up new applications. So let's zoom in to guest access. So to provide guest access to some applications, we just introduced a separate IDP. So this is an IDP that's not connected to the federation because its users are not allowed to use the federation, but we can decide at SurfNet that they can access our services. So users can come either from our federation or from this guest IDP, and it's very easy to hook it up to the PHP software component and select the services that those users can access. Also, we need attributes for some services. For example, the role of the person accessing the service to decide if it can indeed access the service. And because it's cross-service, we need to have an attribute database in a central place. Well, it's a very nice position to have that hooked up to the proxy. So services that can use these attributes. And we're currently also investigating new ways to use this proxy. For example, as an OpenID gateway. We're looking at OpenID as, for example, an alternative to the guest IDP. Because this guest IDP doesn't really know anything about the users. It's a self-service registration service. Well, it's actually very similar to OpenID. So instead of operating this guest IDP, we might as well OpenID account to selected services. So, I have a picture of this in a moment. Let's also look at some other features. For example, federated groups. Often students and they collaborate in groups, and those groups are also used cross-service. So again, this is an ideal spot to administer those groups and add group information before they actually access the service. And we're experimenting with Grouper, which is a product that is developed especially for these kind of federated groups. Federated directory, it's a directory we built on the fly where we can store some user data which can help us, for example, to look up data for specific users. For example, if you want to invite a user to use, for example, to view a certain video in Surf Media, then that we have a problem. How can we identify the user that we want to give access? Well, we can use a federated directory for this. And also this federated directory is connected to our proxy. Another interesting application is the setup authentication that Hans already mentioned. This is actually necessary for some services that require a somewhat stronger form of authentication, because most of our IDPs, they are using simple username password authentication, and for some services this is simply not enough. So what we can do is send one-time passwords by SMS, and in this way we can introduce a second factor for authentication. And one of the nice things we're also doing now is mobile PKI, where we can actually have authentication just like PKI authentication on token, except that the token is your mobile phone. I have a file on this as well. So, This is a picture of OpenID that I mentioned. We can do actually two things. We can have OpenID hooked up to our services by introducing an OpenID provider. So this is just an alternative to the guest IDP I mentioned earlier. And basically this component is a gateway from OpenID to our proxy. And the way this is implemented is actually simply by introducing another protocol handler, an OpenID protocol handler, next to the protocol handlers we already have, like for SAML and A-Flag, for example. What you can also do is hook up OpenID relying parties to our federation, so that users can use their account from their home institution to access OpenID relying parties. Well, it's a little bit tricky because we need user consent for this. Well, luckily, that's one of the projects we're also working on the federation, and the reason is that policy doesn't allow access to services without notifying users and identity providers. You can solve this by introducing user consent. So prior to accessing an external service, the user is asked for consent. Do you really want to release certain attributes to this unknown relying party? Well, to conclude about the step of authentication with your mobile phone, it's actually very simple to integrate it into our proxy because there's a SOAP interface for doing this. Well, the idea is that a user can access the service, but prior, he may already have authenticated by typing in a password at his own IDP, but because stronger authentication is required, the user also needs to sign an authentication request with his mobile phone. And the way this works is that the service can use the SOAP interface to access what is called a mobile signing service provider. And what happens is that on the service page, the user is notified that he has to sign something with some sort of a transaction code. And a challenge is actually sent to his mobile phone through SMS. And what the user sees is the transaction code and a request to sign the challenge with the private key that's on the SIM of his mobile phone. So this is not your ordinary SIM. The SIM has to be provisioned, and there's a whole process in front of this, but it's actually fairly easy to do this. And the SIM also has a special application that's able to do this signing. And the user is asked for his PIN, so this is a different PIN that's used to unlock his phone. It's a PIN that's used to unlock the private key on the phone. So if he does that, enters his PIN, the challenge will be signed with his private key, and the result will be sent back to the service provider. And what the service provider sees is just a digital signature, just as if it were generated with an ordinary PKI token. And the reason we like to have this is that tokens are really difficult to deploy because people need to install software on their clients. They don't bring along the token everywhere. So this is actually a very interesting way to improve authentication. Well, I have a demo. I'm not going to show it here, but if you're interested, I can show it elsewhere. So to wrap up, our federation is now growing, and this is partly thanks to the ease of joining, and that's thanks to the multi-protocol, the protocol translation that we do. So users don't have to do jump to too many to it's from a purely to what we call service, to provide extra services to our constituency. So our NREN has about 900,000 users, so we're halfway, you could say, and things are increasing in speed and connecting these IDPs, and we're working on connecting more and more SPs and increase the use of our federation. So I hope I didn't run too late. Yeah.
Two questions about the mobile PKI and the one-time password. The first is, I've heard that certain phones can be reprogrammed to pick up SMS traffic freely, and that's concern about sniffing one-time passwords. Is the mobile PKI more secure in that respect, in that sniffing won't get anything? And then secondly, how do you connect the phone that somebody has to their particular identity? If they already have had that phone, how do you verify that it's really their phone during the second factor process?
Yeah. So the first question about sniffing, I think it may be a problem for SMS authentication, and we're actually using SMS authentication now, but the idea is that it's more secure to do this with the mobile PKI. So if someone is able to sniff the SMS password, then that's really a security problem. Now for the mobile PKI, that's less of a problem because he can sniff, for example, the challenge being sent, but someone who can sniff this challenge is not able to sign it in a proper way. It may still be a problem because this transaction code is actually used to be able, for the user to be able to make sure he's signing the right thing. So if someone is able to sniff the transaction code, someone else may try to send a fake transaction code where something differently is signed. So that may be a problem. But we're still investigating this. We have a company that specializes in these kind of things, and they are looking at the security right now. So we don't have any results yet, but that's definitely something we will be wanting to make sure of before we actually deploy this. Your second question, tell me here because I forgot what the second question was.
Verifying that the phone is the phone of the right user for one-time code.
Okay.
The standards today talk about SMS being a reasonable second factor approach.
Yeah.
Don't say anything about how you verify that the phone is really in the ownership of the right user.
Yeah.
Will you repeat the question for people that are outside the room?
Yeah. So the question basically is, how do you verify that the phone you're sending a one-time password to, for example, is really the phone of the user? And the way we do this is actually we have an out-of-band process that enrolls users and that makes sure that we have the right phone number. I'm not positively sure that this in all cases means that this is enough. So I'm not too much into this mobile phone technology to see if you can, for example, spoof anything. But we do have the phone numbers, and we're sure that's the right phone number. For mobile PKI, it's a little more complicated because there's an enrollment process that has to make sure that the right person has the right key and the right certificate. So it's initiated in the same way. We have the mobile phone number, but this mobile phone number is associated with a certificate, and the enrollment process makes sure, possibly using a face-to-face procedure, that this phone number is really connected to the right certificate.
Yeah, one question to create a directory. Usually, how do users show up in the directory, and what information are stored there, if any?
Well, I must say this is current development, so we have just a demo, and in the demo, I'm not sure exactly what data is in there, but at least an email address and a user ID, together with an ID of the IDP. And in the demo, we make sure that given an email address, you can look up the identity so that you can uniquely identify a user.
Thank you. I have practiced.
Thank you.
I think there's nice food over there and two nice demos to be watched. One about 3D modeling of human tissue and another one about an unexistent instrument, an epigonion that has been reconstructed using EUMET grid. So it may be interesting to see while you eat.